Hello. Nice to see you. Haven't seen you in a while. All right. Good. All right. So today we're gonna do something a little bit different. We're gonna step away from talking about graphing and all that stuff. We'll come back to it next video. But this video, I wanted to try to teach about a different algebra subject. In this case, exponents. So right here, up here, I have written the exponent rules. There's a lot of different exponent rules, but they're pretty simple. They're not too complicated. All right. So I'll walk through them each one at a time. So I'll keep these rules up here, and I'll work on the examples over here. So these will be examples. All right. So first rule is pretty straightforward. This guy. So let's number these actually. Let's say 1, 2, 3, 4, 5, 6, 7, and 8. All right. 1 and 2, pretty straightforward. Essentially, those x's stand for, they're variables. They can stand for any number, right? So let's say we'll do the number 2. We'll stick with the number 2. The number 2 is going to be our base. So this is called our base. All right? And then the exponent goes on the top right, superscript. It's the top right corner. All right. So in this case, we have to the first power. So it's to the first power. If it's 2 to the first power, that just means 2 times nothing. 2. It means it's equal to 2. If there's a base to the first power, it equals 2. All right. That one's pretty straightforward. That makes sense. All right. Let's do another one. Let's do the number 2. What about if we have 2 to the 0 power? This is rule number 2, right? 2 to the 0 power. What does that equal? 2 to the 0 power. That equals. We can tell from the one. From the rules over here, it equals 1. It equals 1. All right. So why is that important? Because any number. So it can be 1 billion or let's say, I don't want to write 1 billion. So I'm going to instead write 1,500. If it's 1,500 to the 0th power, that's going to equal 1. Any number to the 0th power equals 1. Awesome. All right. So we've gone already over rules 1 and 2. Pretty simple. All right. Let's go with rule number 3. All right. Number 3, we're gonna keep the same base of 2, and in this case, this is interesting. So instead of 2, so it's standard. What you should already know right now, 2 squared. What's 2 squared equal? That's 2 times 2, which that equals 2 times 2, which equals 4. Easy peasy, lemon squeezy. Easy peasy, lemon squeezy. Apparently I say that a bunch. Who knew? That's pretty simple, right? All right. What if we have 2 to the negative 2 power? Oh, I didn't know you could have negative powers. Yes, you can. You can have negative powers. In this case, what it does, it brings the number to the denominator. So instead of being 2 to the negative 2 power, it's 1 over 2 squared. All right. Take a minute. Think about that if it confuses you. Write it down a bunch. Write it down on your worksheet. Make sure that you understand this power, this rule, because it's really important that you understand that. You're going to need that for other equations. And also, we will actually use this later on. All right. Cool. This is a really important rule. One that a lot of kids forget about. All right, next we have, so that's rule number, so let's check these off. Let's rule number 1, taking care of 2. Now we just took care of number 3. What about number 4? So there we have 2 to the n. So let's say we're gonna square it. We're gonna say 2 squared to another power. We're gonna say 2 to the, let's say the third power. All right, here we go. 2 squared to the third power. That's the same. That's what this is. X to the n in parentheses to the n power. Right? That's what that means. What does this mean? What does this actually mean? What this actually means is, what does a power do? Right? I'm gonna write down 2 to the third power as an example. 2 to the third power. What does that do? Oh, look at that. I dropped something. So, 2 to the third power. What does that do? That is 2 times 2 times 2. And 2 times 2 equals 4. 4 times 2 equals 8. So 2 to the third power equals 8. So that's what that does. It means you multiply what's the base times itself 3 times. In this case, we have what's inside the parentheses being taken to the exponent. And essentially, what this is doing is 2 squared times 2 squared times 2 squared. Right, 2 squared times 2 squared times 2 squared. That equals 64, but it doesn't matter what it equals. That's essentially what you want to do here. Is essentially with these. This will take us into the next rule. Actually, what you want to do here is add the exponents. In this case, it's 2 times 2. 2 plus 2 is 4. Plus 2 is 6. So this equals 2 to the 6th power. Instead of adding them, why don't we just multiply them? It's also equal to, and this is the actual rule, 2 to the second power times the third power. So 2 times 3. And 2 times 3 equals 6. It's 2 to the 6th power. So what I was explaining up here is why it leads to the multiplication. Essentially, we're multiplying 2, 1, 2, 3 times. Multiply 2, 3 times, makes 6. Look that over, make sure that makes sense to you. If not, write it down another example. I'll give you another example. Let's go with 4 to the third power to all raised to the 4th power. All right, what's that gonna equal? That'll equal 4 to the third power times 4, which equals, so we multiply this. 3 times 4 equals 12, or 3 times 4? Yeah, 12. So it'll be 4 to the 12th power. Make sense? Hope so. Good. All right. That's also why you need to know your multiplication tables, right? You need to know how to multiply in your head. All right, good. So that is this rule, number 4. But that takes us into number 5. What I showed before, where 2 was 2 times 2, or 2 to the second power times 2 to the second power times 2 to the second power equals 2 to the 6th power, because you add 2 plus 2 plus 2. That's essentially our 5th rule. Boom. So our 5th rule means that if we have a number, let's say 3. Let's say another, I'm going to give you another example. 3 to the second power times 3 12th power. Let's do 12th power. 2 to the 12th power. All right. Or 3 to the 12th power. My bad. I was thinking about 2's, but it's not. It's 3. All right. 3 to the 12th power times 3 to the second power. What do you do here? You add the exponents. In this case, 3 to the second power plus 3 to the 12th power. All right. 3 to the second power plus the 12th power equals, what does it equal? It'll equal 3 to the 14th power. You see that? All right. Does that make sense? That's pretty simple. You just add them together. If they're being if the bases are being multiplied, and if the bases are the same, the bases have to be the same number. They have to be the same number for this to work. All right? It has to be the same. In this case, they are the same. It's 3 and 3. They're the same, so you can add the exponents. You add the exponents, boom, you get 3 to the 14th power. Solve that, then you have the answer. Or you can plug that in the calculator, figure out the answer that way. All right, so that takes care of this guy. If you need another example, we'll play around with these rules more, all right? Don't worry. But I'm just explaining them to you right now briefly, all right? Getting hot. I'm gonna take off my sweater. Now we're on rule number 6. Rule number 6 says, let's do 2, and we're gonna use, we'll use 2 again, but this one will be to the 6th power, and this will be to the 2nd power, and we're gonna divide them from each other. Oh, or actually, yeah, let's divide them. All right. To the 2nd power over to the 6th power. What do we do here? Rule number 6. We subtract the exponents. All right. So this means this will be 2 to the 2nd power minus 6. And 2 minus 6, that equals 4, or negative 4. Equals negative 4. And we're not done yet, because we have to change that negative 4 into positive 4. How do we do that? We bring it to the denominator. 1 over 2 to the 4th power. Boom! And 1 over 2 to the 4th power, that's 2 times 2 equals 4. 4 times 4 is 16. That equals 1 over 16. Easy peasy, lemon squeezy. All right, so yeah. So it looks complicated initially, and then boom, bring it down to 1 over 16. It's no big deal. All right, that's how you deal with these exponents. In this case, you subtract them. In this case, you have to subtract. If they're being divided, you subtract. If they're being multiplied, you add. If they're being distributed, you multiply. Think about that. So, all right, good. So that's taking care of rule number 6. Next comes rule 7 and rule 8. And then we'll play around with these rules. All right, rule 7. X, sorry, not X, Y. We're going to give them numbers. We're going to say 2 times 3. All right, let's since we're multiplying something and it's like that, we're going to say 2 is going to be the base. And we're going to bring this to multiply this by y, and that will be then multiplied by, sorry, that's a y, not a 4, so I'm going to write it differently. Let's go y, like that. That'll be taken to the 3rd power. What does that equal? That equals 2 to the 3rd power. So if you're distributing, that distribution goes to everything, right? That exponent goes to the 2, and the exponent goes to the y. So it goes to the 2 times y to the 3rd power. You see that? That's what happens. All right, let's do this instead of y. We're going to do another number. We'll say 2 times 3 to the 4th power. All right, 2 times 3 to the 4th power. So what's that going to be? It'll be 2 to the 4th power times 3 to the 4th power. All right, doesn't matter. And essentially, this is what that equals. 2 to the 4th power, we know that equals 16. 3 to the 4th power, that's 3 times 3 is 9. 9 times 9 is 81. So it'd be 16 times 81. Which, I don't want to do that in my head. You can do it in the calculator if you want. But that's going to be the solution to this. All right? Welcome back. All right. So what happened here is I multiplied two different ways to solve this particular equation. I'm using PEMDAS and I'm using the exponent rules. First one, the first one I'm using the exponent rules. The second one I'm using PEMDAS. All right. First one, what I'm doing is I'm distributing the exponents. I get this as my solution, 16, and then I get 81. And then I multiply the 81 times the 16, and I get 1,296. 1,296 as a solution. All right. And then I say in my head, wait a minute, PEMDAS, you have to do parentheses first, right? Parentheses are exponents, multiplication, division, addition, subtraction. That's PEMDAS. All right, so then if you need to do parentheses first, shouldn't you do this multiplication first? 6 to the fourth power. 6 to the fourth power, that would be 6 times 6 times 6 times 6. And 6 times 6 is 36. So in that case, it'll be 36 times 36, which is this guy, what I did over here. 36 times 36, and I multiplied it to see if it would work. 6 times 6, and then I multiplied it, and I got the same answer. So, to solve a problem that looks like this, you can either use the exponent rules, which rule are we doing? We're doing number 6 or number 7. You can either follow these exponent rules and distribute the exponent, or you can follow PEMDAS. Do the parentheses first, then the exponents, and then solve it that way. Either way, you'll get the right solution. That's the fun of math. You can figure out new ways to solve problems. In this case, you don't even have to worry about the exponent rules. The reason you do have to worry about them is if you have variables. In this case, we have the variable y. We cannot multiply anything into that variable y because we don't know what number that variable means. So, in that case, you're going to need these exponent rules. However, if it's all numbers, all you need is really PEMDAS and you can solve it. Okay, so that covers rule number 7. Rule number 7. Rule number 8. Last rule. I'm just going to check it preemptively. All right, last rule. So we got, let's say it'll be 3 over 2. And then we're going to say, and the exponent, we're going to distribute the exponent 4. We're going to distribute the exponent 4. All right. So what this is equal? This will equal 3 to the 4th power over 2 to the 4th power. Pretty simple, right? All right. So that one's pretty simple. Cool. All right. What is the importance of these exponents? Why do we need these exponents? Good thing you asked me that, because that'll lead me to the next part of my video, which is, instead of examples, we're going to write problems. All right, problems. And the question is simplify. Simplify. That's the rules. That's what you have to do, simplify. Simplify this expression. Well, how would you do this? You would follow these exponent rules, all right? So you're gonna have to, first, let's deal with the numerator, because that one seems a little more complicated. So in this case, x squared to the 3rd power, what you're gonna need to do is use rule number 4. It'll be x squared times the 3rd over x. All right, so then that's gonna equal x. 3 times 2, that's going to equal 6 over x. Are we done? No, we can still do some more simplifying here. We can simplify. All right, in this case, it's a hidden 1. It's another hidden 1 here. All right, we got the hidden 1 over here. This is x to the 1st power. Because if it was x to the 0th power, it would equal 1 and it wouldn't have a variable there. but it's x to the first power. Because we have an x here, it's automatically x to the first power, at least x to the first power. All right. Unless there's a number in there, it's x to the first power. All right, so we have x to the sixth power over x to the first power. What do we do there? We follow rule number 6. We subtract, right? That'll be x to the sixth minus 1, which equals x to the fifth power. Boom, that's our simplified expression. You can see how this complicated expression turns into a more simple expression. Simple being less complicated, less variables, less numbers in itself. Ideally, you want the least amount of numbers as possible. All right, so that's one example. All right, next we're gonna simplify another example, but this time with numbers. All right, so let's simplify that. Why not? All right, I'm coming up with these examples from my head, so we'll see what happens. I don't even know what's gonna happen. All right, so 3 to the negative fourth power. All right, so what does that equal? What we have to look back at our rules. Remember our rules? That's why practice these rules, write them down, practice these exponents. All right. In this case, you would have to use rule number. Let's see, where is that? Rule number 3. Rule number 3. All right. So this means that we now bring this guy down to the bottom. So it'll be 3 to the fourth power times 3 to the third power to the second power. And then we have 3 squared over here. Looks more complicated, but it's getting simpler. Sometimes you have to get more complicated to become simpler, all right? So now we've just essentially moved this guy down here, and now it's positive, right? If you move it to the other side of the fraction, it's positive. It's the numerator, goes to the denominator, it's positive, all right? So that's going to equal 3 squared, we can do that in our heads. That's going to equal 9. That's 3 times 3, which is equal to 9. All right, and then we have 3 to the fourth power times, so we have 3 to the fourth power times 3 to the third power to the second power. All right, so that's going to equal what? 3 to the third power plus, or times to the second power, times 2, right? 3 to the third power times the second power. Boom. All right, so that equals, so it's still 9 up here. 3 to the fourth power, 3 to the fourth power. Let's keep this as a 3. Let's keep this one as a power of 3, actually. Because we want to keep everything with the same base. All right, 3 squared. So let's go 3 to the fourth power times 3 to the sixth power, right? 2 times 3, 6. All right. Now, we're not done yet. We're almost done, but we're not yet. Now, 3 to the fourth power times 3 to the sixth power. What do we do there? We add, right? Goes 3 to the second power over 3 to the fourth power plus, I'll just write it out, 4 plus 6 equals 3 to the second power over 3 to the fourth plus 6 equals 10. Boom. We done? No, we have one more step. Now we need to subtract, right? We have, let's look at step number 6. We subtract. That would be 3 to the second power minus 10, which is equal to 3 to the negative, what is it? 8. Which is equal to 1 over 3 to the 8th power, which is 3 times 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 3. And 3 times 3 is 9, 9 times 9 is 81, 81 times 81 equals that. Which, I'm not going to do that math. I mean, I'm not going to write that number, rather. 81 times 81, I can do that, but I'm running out of whiteboard space. But essentially, 1 over 3 to the 8th power much simpler than this complicated thing, right? It was an ordeal getting here, but that's the power of these exponent rules. You can simplify this complicated expression into this simple term right here. And that can even be simplified further. If I had a calculator, I need to get a calculator. If I had a calculator, I can easily do it on calculator, boom, have an answer there for you. Cool. So that's how you do that. Easy peasy. It's not easy. Well, it kind of is easy because essentially follow the recipe. You follow the rules. It's like cooking. Some of you might like cooking. Some of you might like making rice, making eggs, making cauliflower casserole or something like that. I don't know. Essentially, you have a recipe that gives you the rules. That's what this is. Essentially, all you need to do in math is memorize the rules, memorize how you do things, and then put them together. And you can make a beautiful mathematical platter as your solution. All right. I'll give you one more example. All right. We're gonna do. What example do I want? Do I want another example? I think we're good. I think we're good with what I have taught you. That'll at least teach you the fundamentals, what you need to know in order to be successful in algebra. You're gonna need to know these exponent rules. It's essential, especially in algebra 2. You're gonna need to know these rules. Where you have 9 to the third power over 3 to the second power. 9 to the third power over 3 to the second power. We don't have the same bases. These bases are different. In this case, what you do, 9 to the third power, 9 can be made by 3 times 3, also known as 3 squared. So it could be, 9 can be expressed as 3 squared to the third power. You see that? 3 squared to the third power is equal to 9. All right? And then we have 3 squared down here. 3 squared. Right? And then distribute that 6. So then we have 3. Or distribute the 3 to the 2. 3 times 2 is 6 over 3 squared, which equals 3 to 6 minus 4. And 3 to the 6 minus 4, that equals 3. 6 minus 4, that equals 2. 3 squared equals 9. Made a mistake. It's actually 3 to the 6 minus 2, which equal to 3 to the 4th power, which is equal to 3 times 3 is 9, 9 times 81. Simple, easy peasy, lemon squeezy. It's easy if you know these rules, if you've understood these rules, if you've tried them out. The only way you're gonna understand these rules, the only way you're gonna be able to solve this question, 2 equal 9. How could you figure out it's equal to 9? Follow exponent rules. You can figure out it's 9. You have to do the work. You have to practice. That's how you learn. Also, homework. That's why we give you homework, so you can practice these mathematical concepts. All right. Keep learning. Make mistakes. Get dirty. Get in there and find enjoyment in math. It's a beautiful path. All right. Have a good one, guys.